Hi, we are from Group 5, Section 3. We are going to share about bar bending and bar cutting. Meet the group members, which is, my name is Nor Batisha Aunibita Herman. The second group member is Cik Wan Nur Izian. Number 3 is Juliana. Number 4 is Nur Hafiza. Number 5 is Putri Nur Akilah.
For in Chapter 1, Introduction, Background Study, the Malaysian construction industry has high rate of accident due to poor planning, weak safety control, and lack of management. To tackle this, the government introduced the OSH Construction Work Design and Management Regulation 2024 under the Occupational Health, Safety and Health Act 1994. Inspired by the UK CDM regulation, the new law ensure safety is planned from the design stage, not just on sites. It's made client, designer, and contractor responsible for managing risk throughout the project. Key highlights: early safety planning in design and pre-construction stage. Second, clear responsibility for all parties. Third is competent and trained personnel in key role. And last, proper safety documentation, safety and health file, construction phase plan. This shift from reactive to proactive safety aim to reduce accident, improve project outcome, and build a stronger safety culture in Malaysia construction industry. Okay, next is OSH Act, enforced on 1 June 2024 under the OSH Act 1994 Act 514. This regulation aims to improve safety at every stage of construction project in Malaysia. First, clients they must plan for safety from the start, appoint key role, principal designer and contractor, provide time, budget and resources, submit pre-construction info, and maintain safety file, notify DOSH for project exceeds 30 days or 500% days, penalty for non-compliance up to 500,000 or 1 year jail. Second is contractor. They must manage site safety, training, access control and supervision. Second is provide PPE and ensure worker competency. Prepare emergency plans like fire and flood. Safety requirement, site cleanliness, structure safety, traffic control. And then safe demolition, excavation, electrical work. Then fire exit detection system, emergency lighting. And last, welfare facility, toilet, water and rest areas. Last, designer. They must design to eliminate or reduce risk, ensure safe construction, use and maintenance, and lastly, coordinate with other designers. Okay, next is objective. First is to analyze the occupation safety and health issue in the construction industry. Second is to identify the potential hazards that occur on the construction site. And last is to propose a method to deal with the risk assessment process using hierarchy guidelines.
Chapter 2, I'm going to present Chapter 2, which is the overview of the construction. Reinforced concrete construction relies heavily on bar bending and bar cutting. This process shape and prepare rebar as the structural specification. Bar bending schedule is BBS is used to control quantity and dimension. Accurate bar preparation ensure the structural integrity and safety. Focus on two main phase, which is foundation work and concrete work. Project goal for construction activity is bar bending. Bar cutting are early stage activity in construction, performed manually or using machine bar benders and cutters. Steps include measuring, cutting, bending, tying with wires. It done on engineer design and BBS, handled by skilled worker following quality and safety standard. These are the difference between foundation work and concrete work. Foundation work, the main purpose of foundation work is prepare and reinforce bar reinforcement for structural element, footing, file cap. Uh, Otherwise, the concrete work prepare and reinforce for superstructure elements such as column, beam, slab, staircase, wall. For bar shape, foundation use U-shape, L-shape bar, rectangular stirrup. Concrete work use closed stirrup, L-shape, crank bar, and spiral bar. Equipment to use on foundation work is bar cutting, bending machine, measuring tape, chalk spiller, and bending wires. Concrete work is the same as foundation work, but plus the rebar straightener, cutter, Triton machine if required. The working environment is foundation work is in open space, flat ground, temporary rebar yard nearby, exposed to weather and heavy steel. Concrete work is confined space inside formwork and scaffolding, sometimes at height. PPE requirement is for foundation is glove, safety boot, helmet due to handling heavy rebars. Concrete work is additional safety due to elevation, hardiness, Google, mask, and glove. Coordination that needed is for foundation is steel fixer, site engineers, and supervisor. For concrete work, only bar fixer, crane operator, and safety officer. The common risk for foundation work is manual handling, injuries, falling bar, and tripping hazard. For concrete work, is ice injuries from spark, misalignment in reinforcement, work at height.
Chapter 3 is explain the methodology used in our study. This means the step or method we follow to complete our project. In this chapter, we focus on how we identify and analyze hazard at the construction site. First, we begin with a job hazard analysis or GHA. GHA is a method used to break down job tasks to identify hazard and create safe work procedure. It helps both manager and workers work together to improve safety. There are six steps in GHA. First, select high risk or new job. Second, break the job into small steps. Third, identify hazard in each step. Four, develop ways to reduce the risk. Fifth, train workers using the findings. And finally, review and update the GHA. Next, we look at hazard on construction site. According to the hierarchy guidelines, a hazard is anything that can cause harm. Example include bending or cutting, which involve risks like heavy lifting, sharp tools, flying debris, and loud noise. To reduce the risk, we can provide proper training, arrange workstation safely, and use protective equipment like gloves, goggles, and ear protection. The last part for chapter 3 is about using HIREC guidelines. HIREC is recommended by the Department of Occupational Safety and Health in Malaysia. Some common risks are unsafe work platform, poor waste management, loud machine, and sharp object. To control this, HIREC suggests use warning signs, barrier, noise control, and safe disposal of dangerous items. By following HIREC and safety regulation, companies can reduce workplace risk and protect workers.
Assalamualaikum. My name is Putrino Akila binti Megat Samsudin. I will continue with the type of hierarchy for the bar bending. For the first one, the work activity is handling and lifting bar. The hazard is heavy manual lifting and the cause is muscle strain. The existing risk control is manual handling training and the likelihood is 3, severity is 2 and the risk is 9. Net is walking around the bar. The hazard is lost on the ground and the cause is slipping, tripping and falling. So the existing risk is site cleaning and the likelihood is 2 and severity is 3. The risk is 6 which is medium. Next is storing the bar. The hazard is unstable stock and the cause is foot injuries. The existing risk control is stacked on a flat road and the likelihood is 3 and the severity is 2. sorry, my bad. Severity is 4. The risk is 12. Next is bringing the bar to other place. The hazard is a quick posture, and the cause is back injuries or muscular strain. The existing risk control is teamwork with other worker, and that is carrying the bar. And the hazard is improper handling heavy material, and the cause is fracture or foot injuries. The existing risk control is use safety boots, and that is operating bar bending machine. The hazard is piece point on bender, and the cause is foot injuries. The existing risk control is use the glove. Okay, next I will continue with the bar cutting. First one is measuring and marking bar. The hazard is sharp edges, and the cause is cutting finger injuries. The risk control is wearing glove, and second is cutting the bar using machine. The hazard is flying metal fragment, and the cause is ice injuries. And the risk control is use safety goggle. And the third one is working near power tool, and the hazard is electrical hazard, and the cause is electric shock. And the risk control is generator awareness. And the next is using the cutting machine indoor. The hazard is noise, and the cause is hearing damage and ears injuries. And for the risk control is unaddressed. Next is hot spark, and the hazard is fire hazard near flammable material, and the cause is burn or fire, and the risk control is not applicable. For the last one is bar and after cutting, and the hazard is sharp edges, and the cause is finger injuries or cut, and the last one is the risk control is use glove. Thank you.
Assalamualaikum. My name is Juliana binti Muhammad Sulaiman, and I will explain chapter 4 discussion. On construction sites, bar bending and cutting are very common but also dangerous tasks. Workers can easily injure their backs or muscles from lifting heavy steel bars, especially with poor posture. That's why proper manual handling, training, and ergonomic workstations like using trolley or adjustable tables are very important. Another danger comes from stick bars. If they are not stored properly, they can collapse and injure someone's feet. There also a risk of finger injuries from pinch points in bar bending machines. This can be reduced by installing safety guards and putting up warning signs. Good lighting is also necessary to avoid eye strain during work. When it comes to bar cutting, flying metal pieces can hurt workers' eyes or face. Sharp edges on cut bars can cause cuts and bruises. That's why PPE like gloves, safety goggles, and face shield must be used. Earplugs are also needed because the machines are very loud. Lastly, fire risk may occur if cutting is done near flammable materials. So fire extinguisher must be ready and the area keep clean. In summary, safety can be improved by using training, protective gear, proper tools, and teamwork. Next is recommendations. To keep everyone safe, we must follow engineering standards and regulations when handling dangerous tasks like bar bending and cutting. We need to apply the right control based on the type of hazard. For example, flying metal pieces can be controlled using face shield and guards. Stick bar hazards can be avoided by using proper storage racks as recommended by CIDB Malaysia. Even if the project has a limited budget, many of these safety measures are affordable and practical. While some tools like mechanical lifting equipment may cost more at first, they bring long-term benefits and can be used in multiple projects. Personal protective equipment such as gloves, goggles, and hearing protections is very effective and cheap. Administrative steps like clear supervision, training, and safety signs are also important. By combining all these steps, we not only protect workers but also improve the project's overall efficiency by avoiding accidents. So lastly is conclusion. To sum up, maintaining a safe and productive work site for bar bending and cutting requires us to manage the risk properly. We must use a mix of engineering, administrative, and PPE controls to handle dangers like unstable stack, manual handling, flying debris, and noise. All the safety controls listed in the high-rate table are realistic and suitable for typical construction budgets.
Engineering controls like guarded machinery and storage rack provide long-term safety benefits. Administrative measures such as proper supervision and training ensure safety procedures are followed. And even though PPE is the last line of defense, it is still essential to protect workers. By applying all these safety measures together, we can reduce accidents, create a safer work environment, and support the successful completion of building projects.